Hey everyone, Ronak this side. I hope you all are doing well. So let's see the problem of the day. So the problem here is same as we did yesterday. The total count, we have to count the total number of waviness in given range. So basically, you have to count total number of wave, and wave means waves equal to number of peak plus number of peaks plus number of valley. Okay, and you know peak what is. If 673, if a number is greater than its leftmost and rightmost neighbor, then it's gonna call as a peak, and if a number is less than its leftmost and rightmost neighbor, we're gonna call it as valley. So we have to count the sum of total number of valley and peak in a given range. So suppose we are given 102 to 106. This is nums1 and this is nums2. We have to count the, I mean, suppose we got 103, 104, 105. So here we got one value, two value, three value, four value, five value. So we got five value plus zero peak. So total number of wave equal to 5. Okay, so we have to return the total number of waves same as we did yesterday. But yesterday what we only have the nums2 can only go to 10 to the power 5. Okay, so this brute force approach where time complexity is total number of digit, I mean number of digits. So for that it gonna be okay. But for if we consider 10 to the power 15, I mean calculate till 10 to the power 15 digit by digit, so it gonna take 10 to the power 15 operation. So that might exceed our limit. 10 to the power 15 into number of digits in range. Okay, n2 minus n1. So that's gonna exceed our range. So what we're gonna do here is, instead of doing this, another approach we are going to follow here is, we are going to follow, I mean we are going to do is, suppose we have to calculate from 105 to 205. So instead of calculating x here, what we're gonna do is, we're gonna calculate first y, then gonna calculate y plus x, and gonna do b minus a equal to y plus x minus y, and that's how we're gonna get x. So what basically I'm trying to say, first we are going to calculate the total number of waves, total numbers of waves from 0 to 105, and then we're gonna calculate total number of waves from 0 to 205 and gonna subtract them. So, and after subtracting them we're gonna get total number of, after subtracting them we're gonna get total number of waves between 105 and 205. Okay, so now let's try to subtract, I mean, and how we're gonna calculate the number of waves between 0 to any natural number, like here we have 105. So basically what we are going to do here is, suppose we are given a number 1, 2, 3, 4, 5. Okay, so I mean, and we have to calculate from 0 to 1, 2, 3, 4, 5. Okay, so in between we got a number called 1, 2, 1, and it can be anything. Okay, but it can takes up to 99 combinations from 00 to 99. Okay, it can take up to 100 combinations. So here we got one value. I mean, like from, like we got a value here. So what we are going to do, like 12100 till 12199, we are going to get one value, that was 100 value. Okay, we can got another value or here, but for this number we are going to get 100 value at this. For 121 at this combination we are going to get 100 value. Okay, and and we are going to, I mean, first of all we are going to calculate the count, I mean calculate the number of waves at the current index. For, I mean, 121 we are going to calculate the number of waves and number of combinations from that wave. So at last what we are doing, equal to total number of waves equal to wave plus combinations of that wave. Okay, wave plus combinations that the wave can make. Okay, so how we are going to do is, first of all we have to, I mean, first of all, to calculate the number of waves we have to track numbers like current number, and then previous number, and then second previous number, because I mean, if we want to calculate the number of waves, we at least have three numbers to compare that this is it hill or valley. Okay, we at least have gonna, so at current we are going to compare previous and previous two, and while we are calculating, what we're gonna do is we are going to start from 000 and then till we move forward. So what we are going to do is we have to trace the three indices, and another interesting thing while making this, we gonna counter zero many times. Okay, so I mean we're gonna counter number zero. So what is special about zero is like we have something like 0 1 2. Okay, so I mean if index is here, I mean if this is leading zero. Okay, so we are not going to count leading zero. Okay, and like something if we got 102 and so, and this zero we're gonna count this zero as a number. So how we gonna I mean say if this zero is leading or not. So we are going to do is, so we're gonna use a variable called, I mean, we're gonna trace that gonna by using a variable called started. I mean, is the number started or is it still leading zero? I mean, we can get 0001 if we have four digits. So okay, so we are going to say if is the number started or is it, I mean, suppose we have something like this. Okay, so if index is here, so this is gonna count as started equal to false. Okay, because the number is at started here, and if the index is here, we're gonna count started as true because number is started now. So how we are going to track a variable started to know that, and we also gonna need another variable called type. So what is the role of type? It's also a boolean type. Okay, true false and integer for these all three. Okay, so how we gonna, I mean, well, we are going to use the type to track is it in tight bound or not. So what I mean by saying it is in tight bound or not, so suppose we are something like 1 1 and we are at current index, then how many combination can this number take? This number can take combination up to 000 to 999, that near about 1,000 combinations. Okay, but if we are at number 1 2, and then how many, I mean how many combination these number gonna take? These number can, these number have three digits but it cannot take 999 because we are exceeded limit. We cannot take, I mean 1 2 4 5 6 because we can't go further than 3 4 5. Okay, so we can't go to 400. We are constrained at 345. Okay, so if we are at, I mean we have to tell is it tight or not. So here tight equal to, here basically tat equal to true. Okay, so what we are going to do, if tat equal to true, we are going to set the limit at the, I mean at the next index. Okay, so the limit gonna be the index of this, I mean current index of the value of the current index. Okay, so we are going to set the limit, and then I mean if this is current, because we are going to count the number of waves from the previous, because we have the second previous, we have the first previous, and we have the current. So the number of wave we are going to count is of first previous. Okay, because it is the center element, so we are going to set that if that is 1, we are going to set it as a limit. Okay, I mean limit that index, so it can only go to 0 1 3, and now these two at 0 these two can go to 99, at 1 these two can go to 99, but at 3 again it's gonna become the tight bound. Okay, so now this can only go to 0 to 4. Okay, and then again from 0 this can gonna become, this can only go to, this can go to 99, from 1 it can go to 99, and but at 4 it can only go to 5. Okay, so that's how we gonna get 2 3 4 and 5. So that's the use of tight bound. That's the use of tight bound here. Okay, so now let's see the code, how we actually gonna count the number of waves and the number of combinations of that waves. Okay, so how we gonna count is, okay, so the first parameter we got here is the position. So what position gonna refer? I mean, suppose we have something like 1 2 3 4 5. So if we are at position that here, I mean we can take up, go up to 0 to 9. If it's not tight, if we are at here we can go to 99. If we are at here we can go to 0 to 999. Okay, so position tells us the range, and I mean position tells the range and also point to the current element. Okay, and what's the next, I mean this is previous to, this is the second previous, of the current. This is previous one. This is the current previous of the current. This is tight, so it gonna say the tight bound. We are in tight constraint or not, or it this is started. So this gonna it gonna tell us the we are started yet or not. Is it any we are at any leading zero or not? Okay. So basically how we are going to start is, so if we exceeded the position in beyond the index of string size. Okay. Suppose we are given at 1 2 3 as a string. So if we exceed the position beyond the string size, so what we are going to do, we are going to return 1 and 0. And why we are returning in pair? Because the answer, this is of result data type, and result stores, it's gonna save number of combinations of data wave. Okay, so it's in reverse order. So we gonna return, we got one combination but we got zero wave. If we are at this index, previous two gonna become previous one, gonna become this, previous two gonna become this. So from two elements we are not going to get any wave, so we gonna return wave at 0, but we got a number called 23. Okay, we got a number 23. Okay, so what the first is base case after exceeding, and this is the limit, so this gonna tell us the limit. Okay, so is it tight? If we are not tight, our limit is to 0 to till 9. Okay, suppose we are given at 1 2 and we are string at 1 2 3 4 5 and we are at index here. Okay, so is 2 tight? Yes, 2 is tight. So this is previous one, this is previous 2. So what we are going to do is, if it's tight, so the limit is going to become 2. Okay, we can't exceed 2. And if we are given from 1 2 3 4 5, if we are at 1 1 and we are pointing at here, is 1 and 1 not gonna become tight. Okay, so if it's not tight, so the next element, yeah, this gonna become till 9. So limits here gonna become this, limit here gonna become 0 to 9. Okay, and what we are going to iterate over every digit till limits. Okay, and so first thing we have to do is check the next tight, is next element is tight. So when the next element gonna be tight, suppose we are at 1 2 3, we are given 1 2 3 4 5, we are at currently at 2. So we are currently at 1 1. Okay, so we are currently here, we are currently at here. So is it gonna become tight any way? No, its range is up to 0 to 9, so it's not gonna become tight. If we are at 1 2 and we are pointing at here, is it gonna become tight? Yes, it's gonna become tight 1 2 and 3. So when it's gonna become tight, till this reaches the till d equal, when it's gonna become, when d reaches the limit. So here limit is 1 to 0 to 3. So either d should reach to limit, and another constant is, if it's reached to limit and another is, this already have to tight, to be the next tight. This can't become tight. Okay, because the next tight, it's already not tight, so it can't become the next item tight, it is free. Okay, so to make the next item tight, this should be, under, this should at the ceiling. Okay, so if it hit the ceiling 1 2, it can hit the 3. Okay, so at the limit it become tight. And after that we are we have to check, is it a leading zero or not? Okay, so we have first to have leading zero, we have to first, I mean d equal to 0, we are currently to current element gonna become 0 first of all, and second, if it's not started. Okay, so we are going to get something like 1 2 0, so it is already started, so it can't become a leading 0. And if it's not started, we already got 0 here, we haven't got any number here, and it isn't started, so it's also gonna count as a leading 0. Okay, and if it gonna count as a leading 0, we are going to solve that. We are going to, if it's a leading 0, we are going to call to next position. So we have something like 1 2, we are going to call at next position and passing position plus 1, and pass the previous one equal to 10, previous 2 equal to 10. Okay, so previous one and previous 2 is basically an array. Previous one till 0 to 9 and 10. Till 0 to 9, this is gonna become a proper index, and till 11, this 10 here represents null. Okay, so tell here represent null value. Okay, or not a number, you can tell anything. 10 here represents not, it's haven't started, we haven't got any previous one or previous two. Okay, so we are going to pass if and next at, I mean we are going to pass next at, is it next at or not, and we are again going to pass false because it hasn't started yet. It's also a leading zero. Okay, it's become a leading zero, so we are going to pass it as false. It hasn't started. We pass the next at, and we pass previous and second previous or first previous as 10. I mean that is invalid. 10 here represents null, so this basically become the number hasn't started yet. Okay, it's acts as a leading zero. Now next, and if it's not a leading zero, okay, if we got a zero, we, the first case is we get zero but it already started, or we didn't get a zero. Okay, so first of all we have an integer called bonus. I mean first, so we are going to see that what bonus gonna store. So we have to check is previous to we have any previous to. I mean first of all it should started, so we first, I mean if we are at here, I mean this already didn't started, so first of all it said it have to be started to count the number of peak and valley, and second previous to had to exist to count the number of, I mean to count the, what I'm saying, to count the number of valley and peak. Okay, previous, if previous two exist, previous one gonna exist for sure, and previous two and previous one gonna exist, then we can count is we got, if we got any value or not. Okay, so we have previous two, previous one, we got previous two, previous one, and the current digits. Okay, so what, so we got previous two and previous one and digits. So now we can compare we got any peak or not. So if we got any peak, we're gonna do bonus equal to 1. And what we are going to do with this bonus, you gonna see later. And we are saying next previous. So if it's started, I mean if it's already started, the next previous gonna become previous one. And if it hasn't started yet, so the next previous gonna become 10, that is invalid. Okay, and the next previous one gonna become the current digit, and we are going to then solve, and then we are going to call the recursion function, and then we are going to solve that further. And answer equal, I mean number of count equal to the count we got after solving, and number of wave equal to sub dot wave. Here we got we got the number of wave from there, and plus 1 into bonus, the number of wave, I mean bonus here gonna become 1, so we got 1 wave, and the count here we are going combo, I mean the number of combo this gonna return. Okay, so the number of combination this sub this returns. Okay, the number of combination this have, so we're gonna multiply that combo, and we are going to get that number of wave. Okay, so you're gonna see how we are going to do this on dry run. Okay, so let's dry run it. So here I already did a dry run for number 105. Okay, so we are going to count the number of waviness from 0 to 105. Okay, so let's tell the what's the pseudocode here. First we have to pass position previous one that started. Base case, if it in the exceed the index, return 1 count and 0 wave. Answer equal to 0, 0. Calculate limit, we have to calculate limit. If it's stat, then the limit is the, I mean the position, the number at that position, and if it's not tight, then it will gonna become 9. And now calculate to every index, we're gonna, I mean iterate over every, we're gonna take every element till index. So if, I mean, and first of all we're gonna calculate the next stat. So how we know if it's already tight and current limit reaches the limit. Okay, so current gonna reach limit. Okay, then its next stat gonna become true. And to how gonna we find is it leading zero or not. Okay, so if not started, the number isn't started yet. Okay, so we don't add any, we haven't got any real number, and current element is also 0, so it's gonna count as a leading 0, and we're gonna pass previous 2 and previous one as null. Next start, and the started is false, it hasn't started, and move to next index. Okay, and do answer, I mean gonna add the, we're gonna compound the number of counts and waves. And if it isn't a leading 0, okay, so what we're gonna do, if first we have to check is it already started. Okay, so if it's already started and previous to also exist, then we are going to check for wave, number of waves, and we are going to do bonus, we're gonna increase bonus by 1. Okay, and if it not started and previous to is, I mean, and previous to it not started, so the previous to gonna become 10, I mean invalid the null pointer, else it gonna become previous one if it started, and previous one gonna become current, and we gonna call it till position, I mean to next position, and gonna pass next previous one, next previous to next stat, and gonna it and true because we actually started here because we got a real element that is not a leading zero. Okay, so we already started here. So if we see the dry run, I mean, let's see the dry run. So the current position at 0, the previous two and previous one is invalid. And is it tight? Yes, it is tight and it hasn't started yet. Okay, so what we are going to do, so 105 we got a d equal to 0, and for d equal to 0 we're gonna check next tight. Is it next tight? So for next tight it has to be tight. So is it tight? Yes, it is tight. So and d equal to limit, so d hasn't equal to limit, so next tight equal to false. And is it a leading zero? Yes, because we haven't started yet and d equal to 0, so it's gonna count as a leading zero. So we're gonna call solve position plus 1. So we're gonna call 1 10 10 next tight equal to false and false. So we're gonna call 1 10 10 false false. So look here, we called 1 10 10 false false. Okay, and I wrote if here because it get called from if statement. So we can do the compounding like we did in if and else statement better while backtracking. Okay, so we called this from if block. So we called this from if block, and at d equal to 1, what we are going to do, at d equal to 1 it switches the limit, so next that gonna become true. And it's already tight and it switches the limit, so next that gonna become true. And it isn't 0, so bonus equal to 1, bonus equal to 0. So is it started? No, it hasn't started yet because we got started as false. And is next previous to it is started? No, so next previous to, I mean next previous to gonna become 10 and next previous one gonna become 1. Okay, so now we're gonna call position plus 1, next previous two gonna become 10, next previous gonna become 1, next that gonna become true. And as it started, yes, it started, we got 1 as next previous. So 1 10 1 true true. Okay, so we called 1 10 1 true true here. Okay, so now we have to call for 1 10 10 ff. Okay, from if block. So if you see, we called from 1 10 10 ff. So here we got 1 as previous element, so we are going to call it from, and 10 10 we got previous one and previous two at invalid, and one is current index. So we got 105. From 105 we are currently at here, we got 2 10 10 ff. Okay, 2 10 10 ff. Okay, so we are currently at, oh, we are at 1 10 10 ff. We are currently at 1. So we are currently at first index. So we got previous one and previous two as invalid. So we are going to check the limit. Is it, I mean, we are going to check the limit. So is it tight? No, it isn't tight. So limit gonna become 9. So limit gonna become 9. Limit equal to 9. And we have to count this. So first d equal to 0. Is it next tight? So next tight, for next tight is this has to be tight. So it's always gonna false from 0 to d equal to 0 to d equal to 0 limit. It always gonna become false because next tight isn't tight. And to become next tight, the current tight has to be true. So it always gonna remain false. And after next tight we are going to count, is it started? No. And is it 0? Yes, so it gonna count as, I mean, a leading 0. And we are going to call previous position plus 1, that is 2 10 10 false false. Okay, so we have to call 2 10 10 false false. So we called 2 10 10 and false false. And for d equal to 1, what we are going to do, for d equal to 1 we are going to, I mean, next at it false. And is it started? No, it hasn't started yet. And is next previous to, it hasn't started yet. So next previous gonna become, I mean, next previous to gonna become false. Next previous gonna become current, that is d equal to 1. And we gonna call next to 1 10, I mean false, I mean that is 10 to 1 10 false and true, because we started yet, because we got a next previous equal to 1. We got next previous equal to 1. So we have to call 2 1 10 ft. So we called 2 10 1. Okay, 2 10 1. This is previous 2 and this is previous one. 2 10 1 ft. So we called 2 10 1 ft from else block, and for d equal to 2, we got started equal to false, and next previous to started equal to false. So next previous to remain gonna become 10, and previous one gonna become current, that is 2. And similarly for d equal to 3 4, and we gonna do similarly for 3 4 5, all remain gonna same. So we have to call these many functions for all of them. So we call 2 10 10 2 10 3 ft, 2 10 4 ft, 2 10 5 ft till 2 10 9 ft, because 9 is the limit. Okay, so we called this as second, we called this, and if we have to, and now we got this 1 2 3 4 5 6 7 8 9 10 10, and this one 11 function in our call stack. So first we wanna call this. So I'm going to call that later. First call it. Okay, so here we got 2 10 10 ff. Okay, so for 2 10 10 ff, so we are at second index, and 2 10 10 F we hasn't started yet. Basically we are at 0 0. We got previous one and previous two as invalid. We hadn't started yet, and we are currently at 5. Okay, so d equal to limit equal to, is it that? No, so limit gonna become till 0 to 9. Okay, limit equal to 9. So at d equal to 0, next at can never become true because it already not that, so it's gonna become 0. Next at always gonna become false. And for d equal to 0, it has a started here, so it's gonna count it as a leading 0. So it's gonna call 3 10 10, next at always remains false false, so it's gonna call 3 10 10 false false. Okay, so it called 3 10 10 false false from if block, and now at d equal to 1, we got we haven't started yet, so we got previous to equal to false, I mean invalid, that is 10, and previous one we got current, that is 1. So we are going previous one, so 3 10 1 ff. So 3 10 1 f. Okay, tv, because we started yet, 3 10 1 ft, 3 10 1 ft, and similarly one gonna till 9 3 10 1 90. So 3 10 9 ft. Okay, so we got this many these all, and similarly if we do for 2 10 1 ft, for 2 10 1 ft, what we are going to do is true. Okay, 2 10 1 f and true, we are at currently. So 2 10 1 f true, so it's the number is started yet, and limit gonna become, is it that? It isn't, so limit gonna become 9. So t gonna become t equal to 0 to 9. And is it a leading 0? No, because we already started yet, and opponents equal to 0, but previous to equal to 10, so we can't count it as, we are not going to calculate peak or valley because previous to equal to 10, and so it started equal to true. So what previous one gonna become, previous two gonna become previous one, that is previous two gonna become previous one, and previous one is, previous one is 1, and next previous two is 1, and previous one is next previous one is the current digit, that is 0. So we're gonna call again the position plus 1, that is 3, and next previous two is 1, next previous one is 0, next at is we is next at is false because we are not going to get next at because current at is already false, so next at always gonna remain false, and true. 3 1 10 ft. Okay, so we called 3 1 0 ft, and for d equal to 1, the only next previous one gonna change, so 1, and this gonna become right. So 3 1 3 1 1 ft, 3 1 9 ft. Okay, 311 ft till 319 ft. Okay, so similarly for this we got 30. If we calculate for this, here previous one only, here, the current element is gonna change till the previous one got, oh shit. If you see this, this is the previous one. So previous one gonna change from as d changes, so it gonna change from 0 to 9, and this is previous two gonna change as previous one changes. Okay, so previous two is changing as previous one is changing, and it is changing at every loop d. Okay, so we got two, I mean at previous two we got 10 calls, at previous 3 we got 10 calls, at previous 4 we got 10 calls, at previous 5 we got 10 calls. Okay, so here total number of calls made was 90 call. Okay, because we had 10 10 10, and this is 9 0 1 to 9, and this is 0 to 9, so this is 10 and this is 9. Okay, so we total got 90 calls here. And what it all gonna return? Okay, so what 3 10 1 ft gonna return? Okay, so we are at 3, we exceeded the limit, so it gonna return, I mean it gonna return one count and zero wave. So it returns one count and zero wave. Okay, it return one count and zero wave. And if from if block, and if it all return gonna one count and zero wave, one count and zero wave, but we are at, I mean we this all gonna, these all statement gonna call from else statement. So else statement gonna return, there is the compounding here gonna become first one return 1 comma 0. Suppose first returns 1 comma 0, then second returns 1 comma 0. So what the total answer gonna become is count gonna become 2, and number of wave gonna become, because we got bonus 0 everywhere. Okay, we haven't count any peak or valley yet, so it gonna become, it's become current, that is 1 plus 1. Okay, 1 plus 1, and it gonna become 0 plus 0, means 0 plus 0 wave, total number of wave plus current wave, and plus it gonna count number of bonus into number of count. Okay, it gonna count number of bonus into number of count. The bonus is 0, so the count, it all gonna contribute 0, so it at the end it gonna become 2 0, and then 2 0 plus, then it again return another third call gonna return 1 0, so it gonna become 3 comma, I mean 0 into 2, and again it gonna 4 into 0 into 3. Okay, like this it gonna compound. So after compounding, it gonna become 9 comma 0. At last it's gonna become 0 into 9. So that 0 plus 0 into 9, I mean 0 plus 0 plus 0 into 9. Okay, so at the end it gonna return 9 comma 0 1 comma 0, and this all gonna compound to 10 comma 0. So we got 10 comma 0 here till answer. And from these all, we similarly we got 1 comma 1 comma 0, we got 10 comma 0. Basically, if you see the number here is, it is count from if, so it is a, I mean we are at index 1, so it is basically 0 0 and space. Okay, and it is basically, it is also count as we are at current index at 0, so we are going to previous, so it is a complete null, we are at here. Okay, and it is 0, and we got two more, it basically counts 0 0 and one more, and these are 0 0 1 0 0 2 0 0 3 0 0 4. These are the actual numbers that we are calling. Okay, till we are going 0 0 1, this is 0 0 and it is 0 0 9. Okay, so here we got 0 0 0, from 0 0 9 we got 10 numbers, and after 10s we got 10 as count and 0 wave, because from 0 to 9, I mean 0 to 9 we has 10 number, but number of waves equal to 0. Okay, so what basically it means, and from here we got first one here. Okay, I mean here we got nothing, here we got 0 and 2 space, here we got 0 0 and 1 space, here we got 0, and here we got 0 0, and here we got 0 1, because 1 is the limit. Okay, so from 0 1 we are going to do, I mean one is, I mean basically one is not the type, so we can go to 1 2 3 4, so it is 0 1 0 2 0 3, I mean 0 1 and space, 0 2 and space, 0 3 and space, 0 4 and space, so it is 0 0 1, I mean it is 0 0 1 0 0 1. This, look at here, 1 11 12 till 19, this represents 20 21 29, this represents 90 91 99. Okay, so you can see the number here, this represents 0 1 0 2 0 3 0 4 till 0 9, this represents 0 0. Okay, and this represents till, I mean 10 to 19, this 20 to 29, and this 90 to 99. So this whole chunk represents 10 to 99. Okay, I mean, yeah, 10 to 99. So that's our total gonna become 90 numbers, and this represents 10 numbers. So at total we got 100 numbers here. At total we got 100 numbers here. And now this was, we got 0 till 100 here. Okay, I mean 100, not, I mean 0 to 99, 100 numbers here. Okay, 0 to 99, we got 100 numbers here. Now we are left to 100 to 105. Okay, so how that those call gonna make, because we are going to get waves there. Okay, so from we left it at 110 true true. Okay, so let's call 110 true true and see what's it gonna return. 110 true true. 110 true true for 105. We are at here. So I mean we got started equal to true, we got start equal to true, so limit equal to, I mean first of all we have to calculate the limit, so limit equal to, we got start equal to true, so limit gonna become the value at current index, and current index is 1, and value at 1 equal to 0, so limit equal to 0. So d can only iterate from 0 to 0. D can only iterate from 0 to 0. Okay, so we are going to get only one loop, and the loop is d equal to 0. Next state equal to is current state equal to true, yes, and d equal to limit, yes, because 0 is the limit, so next state gonna become true, and next state gonna become true, and started equal to true, but we go as any previous two, but previous two is false, so we are not going to count any peak or valley, and yet previous two is false, so and it is started, so previous two one next previous two gonna become current previous one, that is 1, and next previous one gonna become current, that is 0, and we are going to call this as index plus, that is we are going to call it second index. Previous 2 is 1, previous 1 is 0, and next is it next state, yes, next state equal to true, and it is true because number is started, so we are going to call 210 true true. So we call 210 true true, and now let's see 210 true true what it gonna return as. So for 210 true true, this is start, this is start, and 105 we are at second index. So what it gonna return is next state, I mean we have to calculate the next state. So at d equal to 0, next state equal to false, because d equal isn't equal to limit, so next state is false, and next state is false, and it is already started here, so it gonna not gonna count as leading 0. So we got started equal to true, previous to equal to 1, and previous we got previous to equal to 1, previous equal to 0, and current equal to 0. So we hasn't got any peak or value, okay, because this is greater than equal to, so we didn't get any peak or value, so we skip the if statement, and next previous to gonna become current previous one because it's already started. So current previous one is 1, I mean current previous one is, yeah, it is 0, so it gonna become 0, and next previous one gonna become current, that is 0, and we are going to call this as from next index 0 comma 0 and false, next state is false, and but it already started, so ft 300 ft, so it's gonna call 300 ft from else block. Okay, so keep it in mind. And now at d equal to 1, next false equal to previous to 0 0, and this gonna become 1. Okay, we got previous 1, previous 2 at 1, previous 1 at 0, and previous 0, I mean current is 1, so it gonna count as a value, so we are going to do bonus equal to plus 1. So after doing bonus equal to plus 1, we are going to call 3, and d it gonna become 1 3 1 1 false true, 301 false true, so we call 301 false true, and we are going to, I mean store that bonus, so at further while backtracking we gonna track that one, and similarly we are going to call to 2, 3, 4, 5 till the limit, and at limit we're gonna return true. Next state gonna become true, and till then it gonna remain false. So we're gonna, stack that in our call stack 1, 2, 3, 4, 5, and false true, and at last the both gonna become true. So here we got true true till then false true, and here we got false true at 0. So now call these. Okay, 305 true true. So what if we call 305 true true with bonus 1? It gonna return 1 comma 0. And how we gonna compound this? So for a moment, let's start calling it from here. Okay, 300 false true. So if we 300 false true, so 300 false true with in bonus equal to 0, it gonna return 1 comma 0. Now it gonna return 301 false true. It also gonna return 1 comma 0. So it also return 1 comma 0, plus we have bonus 1. So we are going to do bonus plus count, and we got count equal to 1, and bonus plus count equal to, we got a bonus plus count. So, and we're gonna add this also. So now this gonna become in 2 comma 1. Okay, so from 2 comma 1, this is the first call, this is the second call, and this is the third call. Third call gonna also return 1 comma 0, and we have bonus equal to 1. So we got a bonus and to count, and count here we got is, so current count times 1, and we are going to sum it. So it gonna become 2 plus 1 3, and sum it 1 3 comma 1 plus 1. This gonna become 1 comma 1, and 1 comma 1 plus 2 comma 1 equal to gonna become 3 comma 1. Okay, I mean 3 1 plus 1 gonna become 2, 3 comma 2, and after fourth call it gonna become 4 comma 3, and after fifth call it gonna become 5 comma 4. Okay, because we got bonus here also. I mean 1 times 1, we had bonus here also, and at fifth call 0 1 2 3 4 fifth. I mean fifth call we gonna become 4, and at sixth call we gonna become, we got 5 bonuses. So we got 5 wave basically, 1 2 3 4 5. Okay, so we got 5 waves. Now after compounding them all, we got 6. We're gonna get return 6 comma 5. So we returned here 6 comma 5 and 6 comma 5. We are going to add 100 plus 6, that is 106, and 0 plus 5, that gonna become 5. Okay, so the total number of waves we got here is 5, and the number of count here is 106. Okay, 106. I mean we counted 106 numbers. So for, I mean what this all call represents. So if I have to show, I gonna show it like it gonna represent 000, it gonna represent 001 to 009, it gonna represent 10, 11, 12 till 19, and from 20 to 99. It all 2 digits number, and these all represent 3 digits numbers. This gonna, it represents, here we have 105, it represents 105, 105, and it represents 100. Okay, and so it represents 100, 200, 105. All the green call stack represents a number. Okay, because we exceeded the current equal to here, we are counting previous here, so it all represents a number. We are counting waves at previous one. Okay, so 100 to 105, and these all represents 10 to 99, and these represents 1 digit number. They all represent 2 digits number, and these represent 3 digits number. Okay, so we got this. So that's how we're gonna calculate 0 to 105. Okay, the total number of waves from 0 to 105. And if you see the code here, for now ignore the commented code. I'm gonna explain it deeply later, and that's very simple. So here is the current code total, and we are going to call this as solve. Solve is returning the number of count and number of number of count and total number of what we said, the waves. Okay, so we are going to call the solve, and we are going to modify the solve because by this gonna return only waves, and we are going to convert that string into number, and we are going to return the number of waves that gonna, that gonna have from 0 to that number. Okay, and we are doing the difference of those two to return this. Okay. So, and what is this commented code? So I have to explain. So we are using kind of dynamic programming to store the already visited value to reduce the number of counts. So basically what this represents, okay. So these basically represent, okay. So if you try to visualize 1D array, you're gonna visualize it as row. If we want to visualize a 2D array, you can visualize it as a grid. And if you want to visualize a 3D array, you can visualize it as a, I mean, cube kind of something. And for 4D array, we can't basically visualize a fourth dimension, I mean, a hyper dimension. So what we are, instead of visualizing these all, we are going to, I mean, just what we are going to do, you just remember that at every permutation PNC of this number, here we got indexed 0 to 20, here we got 0 to 11, here we got 0 to 11, here we got, I mean, 2, okay, 0 to size is 21 to 20, 1 to 11, here we got 1 and 2, okay. So at any combination, suppose we pick a number 19, 3, 6 and 1, okay. So this basically represents an address in any seat or any hyperdimensional space. This represents an address, and that at that address we're gonna store results, okay. So what result gonna store at that address? We can store the number of count and the number of wave. So that's gonna reduce the time complexity by, I mean, already retrieving that data if we had the data in our result DP, okay. So why we initialize 20 here? Because we are going to get number of indexes we are going to get is 15, but for safer we are going, this basically represents the position. So for being safe, we initialize this as 20, and this represents the previous two, that 1 to 9 and 11 to store 10, and this also represents 1 to 9 and previous one. This represents previous one, this represents previous two, and this represent is it started or not, okay. And why, if you think why we haven't considered the, I mean, tight, is it tight or not? Because we are going to retrieve data when it's only tight, okay. I mean, for now we have like something 1 2 3 4 5, okay, and we are at 1, I mean, we are at 1 1, okay. So how many combination these gonna return? How many combination these gonna return? Okay, it gonna return 999. And if we are at 1 0, how many combinations these gonna return? We gonna return. So these have same number of combinations, I mean, these gonna have same number of combination and waves too if it contains further, if only if it is not bounded, okay. So if it's bounded, if it's tight, so it gonna reduce to 3 4 5, okay. I mean, it's only have 3 4 6, and this 5,000. So we got a number difference here. So, okay, so we are only storing it and checking it if it's only tight, okay. So tight always gonna become 1, so we are not storing. And same we are doing in another boolean array visited, I mean, boolean hyperdimensional space. So space to mark is at visited. So if while storing, what we are going to do is mark that as visited and store that, okay. And while searching, we're gonna search at visited array. So if visited, we're gonna retrieve that data and stop that and move further, okay. So how we are going to do that is first create these two, okay. Then we have to only catch the non-tight state. So if it isn't tight, we are going to mark this, I mean, if it, okay, first we have to store this. So to store, we are going to do this if it isn't tight, okay. We are going to mark that as visited and store that, okay. And while retrieving, if it isn't tight and is this visited, okay, this have to, I mean, marked visited and this isn't tight, then we're gonna return this, I mean, retrieve this and return this, okay. We don't have to do the further calculation. And while passing every new query, we have to reset for both query. We have to initialize it visited from 0, and that's how the total code and total code gonna work. And if you submit this gonna work fine, okay. So that a beautiful dynamic programming question that you have to solve. So the time complexity here gonna become number of digits into 10 square, I mean 10 for previous 10 for previous one combination and 10 for previous two combination. Okay, so that's gonna become time complexity, and same as the space complexity, number of digits into 10 square. Okay, so I think that's it for today. I hope you like this beautiful video and beautiful explanation. So please make sure to subscribe to Tensor. That means a lot for my effort. And till then, keep smiling, keep coding, and feel free to ask any doubts if you got in comment sections.